Two brothers from the Montgolfier family made the very first manned flight in 1783. It consisted of a 5-mile flight above the streets of Paris. Another pair of brothers famously developed the forerunner of today's pressurized spacecraft in 1934. These famous brothers were Auguste and Jean Piccard. The brothers designed and invented a bathyscape, which contained a pressurized cabin and an artificial atmosphere for use in deep-sea research. It was the first such invention of its kind. The same techniques for this invention were used years later in the construction of a gondola, which was carried by a hydrogen balloon to the stratosphere, the opposite extreme to their original deep-sea invention. The flights completed by the Piccard brothers led to the creation of complete environmental systems, which led to the ability to perform spaceflight. It is necessary for human survival in space to have a pressurized cabin. Spacesuits also need to be pressurized for EVAs and times when the cabin is not pressurized. The Piccard brothers also created such things as pyrotechnic devices to make possible explorations high above ground. These devices are explosive systems used for many purposes during spaceflight, such as separating launch stages, modules of spacecraft, and cutting the lines of parachutes after they had served their re-entry purpose. Here, Professor Piccard is demonstrating the pyrotechnic device used for releasing ballasts from the balloon gondola. It works by placing a blasting cap in the center of the bag, which is then filled with sand. From within the gondola, an electric contact is made, exploding the blasting cap and puncturing the bag safely. That particular device was specifically credited with saving the lives of Professor Piccard and his wife, who accompanied him as an official photographer on flights. The pair were the only ones to successfully make a stratospheric flight in the 1930s, where they had to fly through clouds. Others died in these conditions. The balloon itself was inflated with 700 cylinders of hydrogen. Only a little gas is needed. This small amount of gas marks the difference between a stratosphere balloon and an ordinary balloon. In a stratosphere balloon, a small amount of gas is put into the top of the balloon until it's about 1/10 full. When the balloon is fully inflated, it's held by ropes until liftoff. 300 volunteers gathered to witness the event and to lend a hand. Out of all of them, only 6 had ever seen a balloon before. On the signal, all of the men moved forward a given amount so that the balloon rose evenly on all sides. The stress on the balloon became apparent at this stage. The lower part turns up inside and presented a remarkable sight. If they had taken off at this point, the stress on the balloon would have been too great and would have resulted in the material tearing in flight. Thus, the appendix is opened, allowing air to flow into it, making all of the folds free and easy. The gondola is attached to the balloon by the load ring, and the load ring is held by 4 heavy ropes. The white bags above the gondola holding the ropes to the balloon are rigged with TNT and will be the first pyrotechnic device ever used to release an aircraft. Paul and Donald, Professor Piccard's 2 sons, were in the foreground. At 6:58 p.m, there is takeoff from Dearborn, Michigan. Professor Piccard's wife is on top of the gondola, awaiting the signal from Ed Hill to cut the 4 ropes. As the ropes are cut with pyrotechnics, the gondola begins to arc back towards the ground. A command to get under the balloon and push us up comes from the gondola. Note at the top of the picture that the balloon shows no stress on the material and is free of strain. The gondola is painted black on the bottom and white on the top to control the temperature. Inside the gondola, it is 67 degrees Fahrenheit, whereas outside, the temperature is at freezing point. The gondola itself is made of aluminium alloy, only 1/8 of an inch thick. The rate of ascent is 200 feet per minute, and when they get above the clouds, the ambient pressure is so low that their onboard supply of oxygen begins boiling off too rapidly. They quickly close the doors, which results in a hermetical seal for the gondola. Their environmental control system, dubbed air conditioning, is made up of liquid oxygen for breathing, an electric fan to circulate the air, a barometer and thermometer, silica gel to keep the air freshened, androus magnesium perchlorate to absorb moisture, and alkali to absorb carbon dioxide. Throughout the mission, the air is tested continuously for purity and was consistently in very good condition. However, the wireless did not display these same characteristics and subsequently failed. The view out of the top of the gondola demonstrates how the balloon breathes as air is forced into the open appendix. When the descent begins, there is no gas present. Thus, the landing procedure is similar to that of a hot air balloon. After cruising over the top of clouds just below 10,000 feet, they finally land in some trees. The balloon is subsequently punctured by the trees.